back to Structural Analysis Hour. For those of you following along at home, we're working on problem 3-44. The problem consists of a K-truss with two 3-kip forces pulling down on the first two nodes and two 5-kip forces pulling down on the second two nodes. We're solving for the internal forces in member HI, HL, and CD. The first step is to solve for the reaction forces on the supports of the bridge. Follow me over to my calculations. The first step is to solve for the forces in the x direction, in which there is only one, AX. So we know that AX is just equal to 0. Solve for the sum of the forces in the y direction, and you have the upward force of support F and support A, which equal the downward force of our 4 forces pulling on the bridge, which is 16 kips. The last step is to solve for the moments about support A. When you do this, you've got the upward force of Fy times its 150-foot moment arm. Set that equal to the downward forces of our 4 forces pulling on the bridge times each one of their moment arms. When we solve for the force in the y direction of support F, we get 8.8 kips. When you plug that back into our summation of the forces in the y direction, we get that AY equals 7.2 kips. So to start solving for the internal forces, we're going to use the method of sections. To do this, we're going to make a cut through member HI, IL, LC, and CD. Now Stephen will take it away on the method of sections.
Thanks, Jake. Now that we have made our cut, we can reanalyze the truss. We're going to be assuming that the members are in tension until we have computed the actual values. So the first thing we will be finding is the force in member IH. Now, if we do a summation about point C, we can cancel out all the forces coming off of C, and then we can use the rest of them to find IH. Now we will be assuming that all counterclockwise moments are in the positive direction. We'll be starting with our force at force due to the reaction at point A is negative 7.2 kips times the 60 feet of the moment arm minus the force of Fi of IH times its moment arm plus the 3-kip force times its moment arm. And from there we can compute FIH as 17.1 kips in compression. From there we can use the sum of the forces in the x direction, FIH plus FCD equal to 0, and we know that FCD is equal to 17.1 kips in tension.
Now back to our original truss. Now that we found our forces in IH and CD, next we're going to find the force in HG. In order to do this, we're going to have to make another cut using the method of sections through members HG, HM, MD, and DE. Now as you can see, we've made our cuts, and here are our forces that are in the members that we cut through, and all of the original forces that were part of the truss. In order to find the force in HG, we're going to take the moment again at D. You walk over with me over to our equation here. We have the net moment at D equals 0. We have our reaction force times its moment arm, and then the two other forces that are loading on this truss, as well as our negative force, Hg, times its moment arm. Once we solve for that, we find that the force in Hg is 18.9 kips in compression.
It's Mojo time!
Mojo, or the method of joints, is another means of analyzing truss structure. Looking at joint H, we have two unknowns here in FMH and FLH. However, if we look at the summation and the forces in the x direction, we can get rid of this force and only look at this one.
As Stephen just said, we're taking the summation of the forces in the x direction so that we only have force LH as our unknown. So we have our two known forces that we've already calculated, and now we set those equal to the force in LH times the cosine of the angle of its position. And using that, we find that LH is 1.9 kips in compression.
And now, for our final solution.
Force in member IH is 17.1 kips compression.
Force in member CD, 17.1 kips in tension.
And the force in member LH is 1.9 kips compression.